who's here? Yeah, Gideon. Yeah, Derek. Yeah, I'm waiting for the rest. Yeah, Mechlin 360. Sorry. Oh, there's just one person here. Okay, so I'm beginning with the first question. So we have a cone, and then we are supposed to find the density of the cone and also find the location of the center of mass. And then, yeah, Bobby, I see you. Let's get this done quick. Okay. Hope you guys are ready. All right, Mimi. Let's do this. I want you guys to be solving alongside while I'm doing, so that if I make mistake, you correct me, or if you don't understand anything, you prompt me. All right. So yeah, we have 6 concurrent views here. I think it's cool. Let's start with this. So we want the first off, we want the density of the cone here, right? So okay, so we want the density, we want the center of mass, we want the mass moment of inertia of this cone. So the first thing we're going to do is to take an elemental mass. So you take an elemental mass, a very small mass here, this cross section. So if you take that part out, you're going to have something like this. And then the radius r will be any radius. It wouldn't be this big radius. This is the actual radius. So the radius, let's say, since it's on the y-axis, let's make it y. All right, any radius y. The actual radius will be big R. And then the height, the height is h. So the height of this elemental mass, since it's along the x-axis, let's name it dx. All right. Then if we want the density of this elemental mass, rho will be equal to dm over dv. Okay, so from here we can say rho dv is equal to dm. All right. Now, what is the elemental volume of this? So this is cylindrical. Because it's elemental, the height is not really slanted. We consider height as straight, right? So it's very small height. So we will not see the slant line here. So because of that, we can consider this as a cylinder. If you are doing that, then our dv will be equal to pi r squared, which is pi y squared dx. So volume of a cylinder is what? Pi r squared h. And this time our h is dx, and then our cross-sectional area, we have y to be our radius. Then we can say that rho into brackets pi y squared dx is equal to what? dm. Now, as you can see, our differential is x and our variable is y, and that means it will be difficult to find the integral. So you need to find a relationship between y and x so that you can make that substitution. So if you consider a line, this line, at x equals 0, y is also equal to 0. So at x equals 0, y equals 0, and at x equals h, y is equal to r. So we can find the gradient of this slant line. So m will be equal to changing x, or changing, so I prefer making x my y, right? Or, well, let's make changing x and changing y. So that would be r minus what? 0 all on h minus h minus 0. So our gradient m is equal to r on h. So from the equation of line, we say y minus y1 is equal to m into bracket x minus x1. So this time our y1 is 0, so y minus 0 is equal to our m is what? R on h multiplying x. So from here we can say that y is equal to the radius over the h multiplying the variable x. So since we know this, we can come back to this formula, this equation, and substitute y. So then we have rho to be equal to, so we have rho multiplying pi into bracket r on h x all squared dx is equal to dm. All right, so if we expand this, then you're going to have rho pi r squared on h squared s squared dx equals to what? Dm. So from here we just have to integrate both sides, and then the limit of x is from 0 to what? 0 to h, sorry, so 0 to h here, and then dm is just 0 to the mass m. All right, so from here rho is constant, pi is constant, r is constant, h is constant. So we have rho pi r squared all on h squared integral of x squared dx, which is equal to what? M. So if we integrate x squared, we are going to get, so let's bring out rho pi r squared on h squared x cubed on 3 is equal to m. So from here we would, the x has element 0 to h, so we have 0 to h here. Then that will give us rho pi r squared on h squared multiplying h cubed on what? 3, which is equal to m. So just make rho the subject. So rho will be equal to, so h power 2 cancel 2, it will be left with 1. So you have 3 multiplying. All right, let me put it well. So rho pi r squared h all over 3 will be equal to m. So from here we can say rho is equal to m over pi r squared h all over 3. I believe we are all conversant with this. Usually most of you or some people might not go through this process and say the density is equal to mass over pi r squared pi r squared h on 3. All right, if you do this is like you are not showing how you obtain the volume. All right, please, if you have any question, let me see in the chat room. And then the handwriting is not really nice, I understand, it will come with time, so kindly cope with it. Okay, so if you are cool with this, then we should move on. So the next one is to find the center of mass of the cone. All right, so we want to locate the center of mass of this cone. Second year, I'm sure you've gone through strength of materials and you've done center of area, right? So the same thing we're going to do here. Now we are going to say the mass, total mass, or sum of mass times x bar. This is not pi, or this is x bar, should be equal to integral of x dm. So still we are using our elemental mass, this elemental mass, we are still using this elemental mass. So if you have this elemental mass and then it has a certain distance x to the center, then if we add all the masses times their distances from the origin and divide by the total mass, where would the center of mass be? That's the idea. So dm. Now we've already established from the previous session over here, we established here that the m is equal to what? Rho dv, and the m is equal to, so let me just write that here. So we said dm is equal to rho dv, and dv is equal to 2 pi y squared dx. And then we also said y is equal to ry on h. Sorry, rx on h. Why am I making these mistakes? Okay, so having established this, then we can substitute these things here. So the total mass m. For questions like this, do you always use this method? Yes, that's what they're actually asking you for, because there are no values, they are just variables. So without going through the method, you're actually not going to get a mark. Yeah, so the total mass multiplying the x bar should be equal to integral x multiplying pi y squared dx, and we know that mx bar should be equal to integral of x multiplying pi. So there's no difference between my pi and the x, so pi into brackets rx on h all squared dx. Okay, so having done this, the rho, so dm is equal to dv times rho, and this is dv, so rho should come and rho should be here as well. So we can say that mx bar is equal to, so rho pi is constant, r squared h squared, they are all constant, so we have pi rho r squared on h squared multiplying s cubed. So you see this x here, this x is power 2, so they become s cubed dx. Then you bring the integral from 0 to h. So mx bar will be equal to, so if you integrate, sorry, this is pi, right? This is pi. So if you integrate x power 3, you get x power 4. So we are going to have pi or rho pi r squared over h squared x power 4 all over 4, and the element is 0 to h. So having done that, then mx bar will be equal to rho pi r squared all over h squared multiplying h power 4 all over 4. H power 2 cancels 2, so we left with just 2. So you have m to be equal to rho pi r squared h squared all over 4. All right, now from our previous, we said what? Rho is equal to this. Come on. Rho is equal to this term here, m over pi r squared on h. So wherever we see rho, we will put m, this is x bar, x bar. So wherever we see rho, we will put what? M over pi r squared over pi r squared h over 3. So total m s cross bar will be equal to total m over, let me make a big, pi r squared h over 3 multiplying pi r squared h squared over 4. So you can see that this 3 will multiply, if you reciprocate this fraction, it will multiply the m. So I'm going to have m pi equals m x cross will be equal to 3 big M over pi r squared h multiplying pi r squared h squared over 4. So pi r squared cancels pi r squared, 1h cancels one of these h, then m will cancel m. So we just have what? X bar is equal to 3h over 4. Okay, that was a question before we move on. All right, Shari. So we are going to solve the next one. No question. Okay, next one. The next one is the moment of inertia. So the moment of inertia, we are looking for the moment of inertia about the x-axis, right? So I is equal to integral of r squared dm. Okay, so this is the general formula for finding the moment of inertia. All right. Now you realize that our elemental mass that we took, our radius was any y value. Okay, so our r here was y, which we don't know, and we've already established that y is equal to r x over h. So, and also the m is equal to rho dv, and dv is equal to pi y squared dx. So don't forget these things that we made, they're very important. So our I here will be equal to integral of y squared into brackets rho dv, which implies integral of y squared rho times pi y squared dx. So the y squared multiplies, and have I is equal to rho pi integral of y power 4 dx. So y power 4, we know y is equal to what? Y is equal to rx on h. So we say I is equal to rho pi integral rx on h up power 4 dx. So we have I to be equal to rho pi r power 4 all over h power 4 h power 4 x power 4 integral dx. Everything else is constant. So here the moment of inertia becomes I to be equal to rho pi r power 4 all over h power 4 multiplying s power 5 all on 5 from 0 to h, and I use I to be equal to rho pi r power 4 all over h power 4 multiplying h power 5 on 5. So h power 4 cancels and it's left with 1. So that means I will be equal to rho pi r power 4 h all on 5. But we know that rho is equal to m over pi r squared h all on 3. So that implies I is equal to m over 3m over pi r squared h multiplying rho pi r power 4 h all on 5. So pi r squared pi r power 4 cancels, h cancels h, so I will be equal to, sorry, the row is what we found here substituted, so this row shouldn't come. Okay, so that would be 3m h all on 5. Sorry, this one, so 3m, so h and h will cancel, so sorry, h and h will cancel, r power 2 will cancel r power 2 to be left with 2, pi will cancel pi, so 3m r squared, 3/5 m r squared, so that is the ix. All right, so any question before I move on with this one? Oh, are you guys here, please? All right, then let's move on. So we are moving on to the rings. So for rings, we consider them to be a slender rod that has been made to form a ring. All right, so why is it not 3 on 10? I'm coming. Where do you suggest? I mean, because there is no 2 anywhere that multiplies the 5 to make it 10. So that's why is it not? Why is it? Why should it be 3 on 10? I'm waiting for you before I move on. Yeah, coming. Edu, so I didn't ask, you didn't complete your question. What should I focus on when asked to derive each of these that you have helped me derive, please? Okay, so you look at, first off, you need to look at the formulas, like this one, like this, right? So I is equal to integral of r squared dm. Okay, so all boils down to the basic concept, and I think we need some time to go through the basic concept, right? So that we can take it. This is the general formula for finding the moment of inertia. This is the general formula for finding the center, right? So you could see that all of them have special formulas, right? And then some basic concepts. So with this one like this, the dm is always something that, okay, the dm is something I can talk about now. So you take an elemental mass, and then, well, I'm trying, but we still have to take it from the basics. All right, so for now, if I want to take from the basic, it will take some time, and we wouldn't finish all the questions. Okay, so let's just move on, get the assignments done. Yes, Larry 6 is your question I'm asking. I'm answering. So thing is, to derive these equations, you have to understand the basic concept behind them, right? Like the formulas I stated before, or the elemental formulas before I integrated. You need to understand those ones before, when you are doing these things, it will be very easy for you. And like I'm saying, if you have to go through the basics now, you wouldn't solve enough of the questions, right? So I would want us to go through. I hope you are doing it with me. So you just notice what you are doing, and then after the session, you want to understand the basics, you can approach, or yes, anything of that sort. All right, because this, for the derivation, it demands the basic understanding. Okay, so I'm going to do the same thing with this formula, with this question. So let's see if you can, or I can explain some of the basic stuff from here. All right, so if you're good, I am. Please, I asked the question. Please, why is it not 3 on 10? Yeah, you asked why is it not 3 on 10, and then I was showing you the formulas we derived. You see, if it will be 3 on 10, it will come from the derivations we were making. So you could see that there isn't any over 2. any here, every over here, right? So I don't know where you're getting the 3 on 10 from. So if you could help with that, then we could look at that. Okay. I actually don't know what the formula is. I'm just following the principle or the concept. Okay, so yeah. Please, shall we move on? Okay, sure. All right, so let's move on. So we have the ring here, and then we need to find the moment of inertia of the ring. So if we draw the ring, we can take an elemental mass, right, the m here. Now, because this is considered as slender, it has no thickness, right? So since we are not considering the thickness, we're going to look at this as a slender rod that has been bent around like this. So we are actually going to find a density to be dm over dl, or we're going to find linear density instead of the volumetric density that we know, right? So dm once again will be equal to rho dl. Now dl, so the distance from here to here is r, right? So dl is just a small distance along the circumference, all right, which is just, so let's say if I have something like this, it's just this that I'm looking for, this distance dl here. So if here is theta, then the dl will be equal to r d theta. Okay, so the m will be equal to rho r d theta. Now we know I to be equal to integral of r squared dm, all right. Mimi, you said if the I is equal to integral of half r squared dm. Are you talking about this one? Are you talking about this particular problem? Okay, that also makes sense. That also makes sense. But let's finish with this. We'll look at that again. So we have I to be equal to r squared dm, and then I will be equal to integral of r squared Now the radius of rotation of this elemental mass to the center is the same for all the masses all around. So the R here is just going to be the big R, and then the M is going to be rho R, so big R squared, rho R d theta. And that gives us I to be equal to R cube integral R cube rho integral of what d theta, and theta is from 0 to 2 pi. So if we integrate that, then I becomes rho R cube theta from 0 to 2 pi, and that gives us rho R cube 2 pi. Now the total length of this rim is going to be 2 pi r. If you cut this and then stretch it this way, then the total length is going to be 2 pi r. So the total density is going to be the m over 2 pi r. So if we do that, then I will be equal to m over 2 pi r multiplying r cubed times 2 pi. So 2 cancels 2, pi cancels pi, one of the r cancels here, so I will be equal to mr squared. All right, so are you okay with this one? Okay, so next question. Okay, so we are supposed to find the, okay, so here from determine the mass moment of inertia of the 3/4 thin ring and the average radius r. So we're just looking for this one. So as you can see, this is the 3/4 of the total over here, right? So it's either we subtract 1/4 from the total moment of inertia we had, or we multiply the total by 3/4. So I'm saying is coming. So from here, the total ring has this moment of inertia. So the one that's a quarter has been cut off, that will be equal to the total mr squared minus 1/4 mr squared, and that will be 3/4 mr squared. Yeah. And then so next one, okay, so we are on this one. Please, with this one, you will help me with the calculation, all right, so that we all get engaged. Okay, so with this problem, there is a hub at the center over here. There is this bicycle tie with a hub and then spokes. All right, so the moment of inertia will consist of the rim, the spokes, and then the hub. Now they said the bicycle wheel consists of thin ring of tie, and then a rim connected to a hub by 8 spokes. the tire and rim have combined, so mass of the rim and then so m1 is equal to 4 kilogram. And then the r2, which is the radius of the rim together with the tire, is 600 mm, which is approximately 0.6 meters. And then each spoke is a cylinder rod, so the spokes are being considered as a cylinder rod, and then they have mass, so mass 2, which is the mass of the spoke, to be was 0.5 kilogram. The hub is a cylinder of mass 3 kilogram, so the hub is considered as a cylinder, and then the mass, which is m3, is equal to 3 kilogram, and then radius r1 is equal to 100 mm. Okay, so we are looking for the moment of inertia yeah, I get it. We'll look at that. Yeah, we'll look at that again, don't worry. I've pinned it so that I don't forget, so thanks for drawing my attention. So let's move on. So we have 8 spokes, we have the rim, and then we have the cylinder. So we are looking for the moment of inertia about the center, and when we finish, we find the moment of inertia about the point A. So IG will be equal to I1, what is I of the I1 is for the mass 1, so mass moment of inertia of the rim plus the tire, plus I2, which is the moment of inertia of the spokes, plus I3, which is that of the hub. So I1 will be equal to, the rim is considered as a what? A ring. So the formula is mr squared. The mass is 4 and the radius is 0.6 meters. So 0.6 squared. Kindly look for the answer and post it in the comment section for me, the chats room for me. And then I2 will be for the mass 2, which is the spokes. So the moment of inertia of the spoke, you realize that we have found the moment of inertia at this point, and the center of the spoke is somewhere here, right? So I'm going to apply what you call the parallax theorem, which is 1/12 ml squared plus md squared. So this will be for each one, a single spoke, then we multiply by 8. Now L is equal to R2 minus R1, and D is equal to R2 minus R1 all over 2 plus R1. All right, so let's quickly find L. So L will be 0.6 minus 0.1, which is 0.5, and then we are going to have D to be equal to 0.5 over 2 plus 0.1, which means we have 0.35. All right, R1 is 100 millimeters, which is 0.1 meters. So if we do that, then I2 will be equal to 1/12, the mass is 0.5, the mass 2 is 0.5, and then we have the length, which is 0.5 squared plus 0.5 multiplying D, which is what? 0.35 squared, all multiplied by 8. All right, so who has done for the I1, please? So I1, we have 4 multiplying 0.6 squared. That will give us 1.44. All right, sure, thanks. 1.44 kilogram. And then I2, what do we have? what do you have for I2? So I'm having 0.573 and then I3. Yay. Okay, so what you guys were saying, Mimi. So moment of inertia of a cylinder I3 is equal to mr squared on 2. So I think the elemental cylinder I took, the moment of inertia is supposed to be the my squared on 2. So you are right over there. So when we make it this way, you should get the on 10. Thank you. So I cube will be equal to mr squared on 2. Now the radius of I3, the radius of the mass 3 is what? R1, which is 100 mm. So we're going to have the mass is 3 kilogram. So 3 multiplying 0.1 squared all on 2, and that will be 1.5 times 0.01. So we have 0.015. So the total moment of inertia I about G will be equal to 1.44 plus 0.5733 plus 0.015, and that will be equal to that will be equal to 2.0283 kilogram meter squared. All right, so having done this, we're going to look for moment of inertia about E, right? And then to find moment of inertia about E, we need to apply the parallelization theorem. So we know the moment of inertia about at G, and then the distance between G and E is what? R2. So IE will be equal to IG plus MD squared, which IG is what? 2.0283 plus the mass is the total mass, which is M1 plus M2 plus M3, and then the D is what? R2 squared. So our mass 1 is 4, mass 2 is 0.5, mass 3 is 3. So we're going to have 2.0283 plus 4 plus 0.5 plus this one again, 3, multiplying 0.6 squared, and that gives us 2.0283. Yeah, I multiplied by 8. I multiply by 8 over here. Or you don't get the same value if you multiply by 8. Let me know what you had. Let me do it again. So 1 on 12. 0.5 squared plus 0.5 squared. Yeah, exactly. So this is what we have now. We have 2.0283 plus 4 plus 0.5 plus 3 multiplying 0.6 squared. So I at A will give us 4.7283 kilogram meter squared. All right, so that is that for the other question. All right, shall we move on? Okay, so the next is all right. So in this question, we have a rotor of variable resistance. If the rotor of a variable resistance motor is made from an iron and has a cylindrical core, so the rotor is the rotating part of the motor. So this part is what they are talking about. So it has a cylindrical core, which is this one, and the mass is 3 kilogram and has diameter due to 50 millimeters, and has 8 extended cylinder rods having this mass and then this. Determine the moment of inertia of the rotor about the axis of rotation. So this is just like what we did earlier, right? The same thing. So I will be equal to I1 plus I2. Okay, now the length. So you could see that the length of the spoke is just at the end of the cylinder. So I1, which will be mr squared on 2. The mass is 3 kilograms. So we have that. The diameter is 50. So radius will be 25, which will be 0.025 all squared all on 2. Then I2 will be 8 times Ig plus md squared, which is moment of inertia about the center of the rod plus mass times the distance from the center of the rod to the center of the cylinder. So we have 8 multiplying 1 on 12 ml squared plus md squared, which is 8 times 1 on 12. The mass of the spoke is 1 kilogram. So we have 1 here, and then the length is 100 millimeters, 0.1 squared plus 1 multiplying 0.1 over 2 plus, so 0.1 over 2. Let me clean this one. So this is the mass, 0.1 times 0.1 over 2, which is half of the length, plus 0.025 all squared. All right, so let's see what we get. So I1 will be 3 multiplying 0.025 power 2 all on 2, and that will be 0.0009 375, and then I2 would be 8 multiplying 1 on 12 multiplying 1 0.1 squared plus 0.1 on 2 plus 0.025 all squared 6. Okay, so I'm getting 0.05166 kilogram meter squared. So our I will be 0.0009375 plus 0.05166, and that will be 0.05 5 here, so 525 or maybe 6 here kilogram meter square. All right, so any question with this one also? Please kindly cross-check the calculations. If I make mistake, you may prompt me. All right, so the most important thing is the expressions. If you have the expressions, you make the right substitution, you should get the right answer. Okay, any question on this? Why are we choosing R squared and as D, R2 as D? You mean this particular question? Okay, this one. Yeah, Mimi. So we want the distance between the axis going through this point. So if the axis is going through like this, and this one is going through here like this, we want a distance between this and this, right? And then this is the D, and you can see that from here to here is the same as what? It is the radius of the whole thing, which is what? R2. All right. Please, if you get this, let me know, Mimi. Shall we move on? Okay, so the next one. Don't you think it's okay with the moment of inertia problems? Okay, so with this problem 6 is this we are looking at. Now they are saying the pendulum consists of a spherical ball of mass and diameter this, and it's worded to a slender rod of mass this and then this. Determine the mass moment of inertia of the pendulum about an axis perpendicular to the page and passing through O. So you're looking for it at this point, and then $5.9. Is it this one? You may kindly reply on time so that we can get along. All right, so our Telegram link is in the description, so you can forward your solution to the Telegram page and then I'll look into it. All right. Okay, so we are working on the pendulum. We are working on the pendulum. Now you're looking for the moment of inertia about this point. So here we have so I will be equal to I of the rod plus I of the sphere. Alright, so I rod will be equal to, now since the center of the rod is somewhere here, if I'm looking for moment of inertia about this point, you apply the paralysis theorem, which will be 112 ml squared plus what? Md squared. Now our mass, the rod mass is 1.5 kilogram and the length is 0.6, and you know the distance from here to here is the length, so half of the length is our what? R. So that gives us 1/12, and the mass 1.5 times 0.6 squared plus 1.5 times 0.3 squared. And then I of sphere will be equal to, so that one, the center, the moment of inertia for a sphere about the center is 2/5 mr squared. So plus what's md squared. Now this time you're going to be half diameter plus what's the L. That would be for D. So we have 2/5. The mass is 4. The radius is 0.1 squared plus 4, and the D is what? 0.1 plus 0.6 squared. So this one will give us 1/12 the mass 1.5 0.6 squared plus 1.5 times 0.3 squared. So this gives us 1.8. Then we have 2/5 multiplying 4, applying 0.1 squared plus 4, 0.1 plus 0.6 squared. This one gives us 1.976. So I will be equal to 1.8 plus 1.976, and that gives us 0.776 kilogram meter square. All right, so now the next is to find the center of mass. So the center of mass, just as we did earlier, is going to be, so m times y bar will be equal to sum of mi ri or yi Oh, a 0 point. Oh, okay, 0.18. What did I miss? Verify the sphere for me. The mass is 1.5, the length is 0.6 squared plus 1.5 again, the d 0.3 squared. So 1 on 12 multiplying 1.5 times 0.6 squared plus 1.5, 0.3 squared. Oh, so 0.18. So that changes the answer. So we have 0.18 plus 1.976, and that will be 0.18 plus 1.976. So we get 2.156 kilogram meter squared. Thank you. So MIYI, which is to say we are looking for the center of the whole object from the O. So we are standing at O. So what you're going to do is that you pick the first mass, you multiply by the distance from its center to O. Then you pick the second mass, you multiply the mass to the length from its center to O. Then we add the two and divide by the total mass, and that will give us the center of the whole assembly from O. So total mass is mass of rod plus mass of sphere, which is equal to 1.5 plus 4. Now M1Y1, which is to say the mass of the rod times the distance from its center to O. So mass is 1.5 and the distance from its center to O is 0.3. And then M2Y2 will be equal to the mass of the sphere, which is 4, and the distance from its center to O is 0.1 plus 0.6. So this one gives us 1.5 times 0.3, which is 0.45. And this one will be 4 times 0.1 plus 0.6. And this one will be 2.8. So total mass, this one is 5.5. So 5.5 times y bar is equal to 0.45 plus 2.8. So y bar will be equal to 0.45 plus 2.8 all divided by 5.5. And that will be 0.45 plus 2.8 all on 5.5. And we have 0.590 or 0.591 as a y bar. Nope. Okay, looks like Mimi is lagging. Okay, so we have the y bar here. Now the next question is what? Determine the mass moment of inertia of the pendulum about an axis perpendicular to the page and passing through the center. So see, if we were to find the moment of inertia about O, then IO should be equal to IG plus MD squared. So now at the y bar, that is the center of the whole assembly, and that's what they're asking us to find the moment of inertia from. So IG will be equal to IO minus what? MD squared. And this is the total mass the d is the distance between the center, which is the distance between the center of the whole assembly, which is y bar, towards O, and obviously that is y bar. So IG will be equal to the IO. Oh, I didn't add the O there, so this is IO, and that is 2.156. So we have 2.156 minus total mass, which was 5.5, multiplying 0.591. Now give us our IG. So we have 2.156 minus 5.5. 5.5 times 0.591 squared. Which one are you talking about? Is it this same problem you're talking about? Is it the M here that you are referring to? Kindly reply on time so that I can. So you, anytime you come in with a question, I want to know which one you're talking about. So yes, we are using the total mass at this point because this is the I naught we found is the total moment of inertia, and we are looking for the total moment of inertia of the whole assembly at G. So since we know this is the total mass, and then the total mass is at the center, right? So at the center of the body, this is the mass that is there, and the distance from that center to the O is the D, which we found to be what? The Y bar. All right. So let's move on. I'm really tired with the moment of inertia questions. All right. Do you think we should solve the rest, the moment of inertia? Because this and that one is the same. I think this one is different. Let me know, should we solve all of them, or we should skip to the ones that we've not solved any example on? Oh, some have even logged that. We have about 15 minutes. Seven. Okay, so hey, I said, oh. Right, sure, you do all of them, but I have to sleep at 10. If not, I will die. So let's see what happens. So question 7, the slender rods. Let me make an emphasis on this. With what Mimi said earlier, it's supposed to be 3 on 10, because I think I explained at the point there. The elemental cylinder that I choose if it's rotating about the center, then I will be equal to 1 over 2 mr squared, my squared, right? So if you do the substitution with the same method we did, you should get the 3 on 10 mr squared. Yeah, so kindly make this substitution, and then that is done. So it shouldn't be 3 on 5, it should be 3 on 10. All right, let's move on. So for this, the slender rods have width density. So gamma equals 4.46 kilogram per meter, and we are looking for the moment of inertia about an axis perpendicular to the page and passing through point A over here. Okay, take, so A is 6, then whatever B is this. All right, sure. So the total length of, how do we even label these rods? So let's make it 1 and 2. So let's make this one rod 1, this one rod 2. All right, or horizontal rod and vertical rod, anyhow you want it. So I at E should be equal to I at I of vertical rod plus I of horizontal rod. So for the vertical rod, we need to locate its center, and its center will be A plus B over 2. That's where its center will be. So I V, because the center, the A is not coinciding with their centers, we need to apply the parallaxis theorem, which we say is what, IG plus what, MD squared. So the IG for all the rods obviously is 112 ml squared plus what, MD squared. So for the vertical rod, yes, so we need to find their masses. So first of the vertical rod, M of the vertical rod will be equal to the linear density, which is gamma, multiplied by the length of the vertical rod, which is what, 4.46 multiplying. So the total length is what, B plus A, which is B plus A. So we have 4.46. B is 300 meters, and then, hey, I'm sure this is supposed to be millimeters, not meters. 300 meters, why? So A is 600 millimeters, B is 300 millimeters. So that will be 900 millimeters. That will be 0.9, and that will give us 0.46. 4.46 times 0.9. So that gives us 4.014 kilogram. And so we know the mass, and L, the L is B plus A, and D is half of what, the length. So I know some of you may be using this formula 1/3 ml squared, right? The same thing. Please touch on the not coinciding with the masses, so elaborate for me. Oh, okay. So thing is, if you see, if this rod, if I have a rod like this, and then I'm finding moment of inertia about its center, then it's just going to be IG, which is what, ml squared on 12. But if it is about another axis other than its center, meaning if it's about a point that is not at the center of the body, then you need to apply the parallaxis theorem. So A is not at the center of the vertical rod nor the horizontal rod. So both of them will involve the parallaxis theorem. That's what I mean by A is not coinciding with any of their centers. I hope that is clear. Okay, so we know the mass. Now the length of the vertical rod is A plus B, which we found to be 0.9, and D is the distance from the center of A to the center of the vertical rod to A, which is what, 0.9 over 2, giving us 0.45. So I of the vertical rod will be equal to 1 on 12 multiplying 4.014, and the length 0.9 squared plus the mass again 4.014 and the d 0.45 squared. All right, lyricists, you're welcome. So what do we get? Oh, kindly do this for me. Kindly find the value of this for me. All right, let's do it together. So we have 1 on 12 and mass is 4.014 multiplying 0.9 squared plus 4.014 multiplying 0.45 squared. All right, I'm getting 1.083 here, 1.08378 kilogram meter squared here. All right, so the horizontal one, the horizontal rod, that one too, this rotation will still be what? 112 ml squared. So for that one, the distance, you just have to find 112 ml squared, and the distance from here to here will be that. See, the reason why I advise you not to use this is what we are having here. You can apply the 1/3 ml squared on the vertical rod, but you can't do the same for the horizontal rod. And people might think anytime you find the moment of Axis theorem for any rod, you have to use 1/3 ml squared. You shouldn't do that. So always use ml squared, 112 ml squared plus md squared, and you'll be in safe hands. So for the horizontal rod, IH should be equal to still IG plus MD squared, and IG is still 112 ml squared plus what? MD squared. Now the mass is, so the mass of the horizontal will be equal to gamma times length of the horizontal rod. Now the length is C plus C, which is 460 plus 460. So we have 4.46 multiplying 2 times 0.46, and that will be 4.46 multiplying 2 times 0.46. So I have 4.1032 kilogram. Okay, so I have the mass. Now the length is 2 times 0.46, but the D is A. The D is the distance from the center of this rod to A, which is the distance from here to here, and that is what? A. And A is 600 mm. So I of the horizontal rod will be equal to 4.1032 all on 12 multiplying the length, which is 2 times 0.46, and the length, hey, that's the length, right? So plus the mass 4.1032, and our D is A, which is 0.6. So IH will be equal to 4.1032 all on 12 multiplying 2 times 0.46 squared plus 4.1032 0.6. All right, so I'm getting 2.751 kilogram meter squared. So we stated earlier that our total moment of inertia about E is what? IV plus IH. And IV is this, IH is this. So our I will be equal to 2.751 plus 1.08378. And that will give us. Please, can you explain the two rotations of a cylinder rod along the end and center? It's confusing. Okay, lyrics. So thing is, you don't need to worry about whether it's at the center or it's at the end, which I stated that forget about that 1/3 ml squared. Later you realize that it's, if you use the general formula, you end up getting the same thing. The 1/3 ml squared is a simple way of finding moment of inertia of a rod if it's about its very end, right? But obviously it's not always like that. Let me find the value before I make a mistake. I'll come back to that. 0.0837. Okay, so I have IA. IA is 3.834 or 3.35 kilogram meter squared. So I hope you're okay with this. Now, lyricist. Then is see, if you are finding moment of inertia about the end here, right? This is a rod, so about the end here, then you're going to have 112 ml squared plus md squared, and the d is the distance from here to here, which is half of the L. So if you make that substitution, you can simplify and end up getting 1/3 ml squared. That's not always the case. You could have a rod and then you are finding the moment of inertia about a point here. So your d is down from here to here, which if you do that substitution, you can't manipulate to get 1/3 ml squared. So always stick to, if it's about the center, if you are rotating about the center, or if the point is about the center of the rod, then that would be what? 1/12 ml squared. 3, 4. Yeah, so I approximated mine. So if it's about the center, then that will be what? 1/12 ml squared. But if it's not about the center, but about any point other than the center, then it's going to be 1/12 ml squared plus the mass of the rod multiplying the distance from the center to the points that you are finding the moment of inertia about. So forget about the 1/3 ml squared. All right, you always end up getting it if it is like that. Okay, my people, if you are good, I'm good. Shall we? The time. Okay, so this question is the same as what we've done earlier, so we'll go and solve this. So with this problem, the only difference is that this time the lyricist, look at something here. You see the rod AB, the O is at the center of AB. So if you are finding the moment of inertia of the AB, it's just going to be 1/12 ml squared without considering the parallaxes. By the vertical one here, you consider the parallaxes, and then in this case you consider the parallaxes. But this time too, the disc here is hollow, so you will find the hey, I have to do this one too. Let's do it. I have to solve few questions and then rest. So for this one and this one, the solutions are in the textbook, so I don't think we have to solve it. And this one as well, but this one we need there are other terms that are not in the book, so yeah. And the airplane too hasn't been solved, so let's see. Please, should we solve question 8 or should we skip? Let me know. Should you solve question 8 or should you skip? And subtract the hollow. Should we solve the question 8 or we should skip, please? Okay, thank you. A lovely people. Alright, now let's come to this guy here. Play. Ernest, you've done similar questions. You've done similar questions, please. You've done a lot like that. Okay, so this guy here. The assembly shown in figure 9 has mass 8 kilogram. MA. Where is A? So this guy here, right? And it is hosted using the boom and pulley system. If the wing at B draws the cable with acceleration A equals 2.5 meters per second square, determine the compressive force in the hydraulic cylinder needed to support the boom. The boom has this mass, and all that. Okay. So the first thing we do is to draw a free body diagram. So if you pick this guy here, there is the hydraulic will apply a vertical force here, and then there is a tension here, and then there are two ropes. Question not too hard. Ant-Man. Okay, so let's move on. Your question. Yeah, you will do that, don't worry. You will do that before I sleep. Okay, so with this mass, if we cut it, if we cut at this end, we have a tension here and a tension here. So we are going to have 2T going up here, and then 2T coming down, and then we have T here, right? So this is what we have, and then we have the fixed point at this end here. Now this one, let's limit the force from the hydraulic, so FH. Okay. Now they said the wing chair is pulling the rope by this acceleration. So from our pulley system, we know that if from here to here is SE, then here is what? SB, and here to be what? SB. So we can say that SE plus 2SB is equal to L, and then VA plus what? 2VB is equal to 0. Right, that is to mean acceleration of A plus 2 acceleration of B is equal to what? 0. Okay, so from here it is pulling it down, so that means we are going down negative, and then this one should move up positive. So A, we are making A to be negative. The acceleration of A should be negative, so acceleration of A will be negative 2.5, and that means negative 2.5 minus plus 2 so 2 acceleration of B is equal to 0. Acceleration of B will be equal to 2.5 from 2, and that will be 1.25 meter per second squared. So now that we know the acceleration of B, now yeah, I didn't add the width, so we have M. This mass is the A, so MAG. So we are looking for this force, right? Now I realize that this tension is passing through this point, so we can't find moments. Oh, before that, we can't talk about that now, but let's so the free body diagram. Yes, the weight of the boom tube, it had a center of mass somewhere here, right? I didn't add that. Now point down, let's name that MBG. Okay, so we are looking for this F. All right, so the simple way to go about it is to find the moment about this point here, and if it's going to provide a support, that means this boom is going to be stable. And if it's going to be stable, then sum of forces on it should be equal to 0. Sum of moment about this point should also be equal to 0. Now we know the distance from here to here, and then from here to here, from here to here, right? So for let me name them for A and then B. So for A, the sum of forces in the y direction should be equal to mass acceleration in the y direction, and then the forces we have 2t minus mag, and that should be equal to what? May. So 2t is equal to m, so that is ma, right? Acceleration of the mass of the A part, so mag plus maa, and so 2t will be equal to the mass A is 8 megagram, and that will be 8,000 kilogram, right? And then B is 2 megagram, and that will be 2,000 kilogram. So we have 8,000 bracket 9.81 plus acceleration, which is what? 1.25. So T will be equal to 8,000 over 2 will be what? 4,000 multiplying 9.81 plus 1.25. So T will be equal to 4,000 multiplying 9.81 plus 1.25. That is 44240 Newton. All right, so now we know the tension. That means we know that this force here, we know the weight, and you know this, so you can take moment and say it's equal to 0. So taking moment at this point, we need this vertical distance for this, vertical distance for this, and then vertical distance for this. So this is B. So the horizontal. So the horizontal distance for this vertical force should be B cos theta, right? So B cos what? Theta. And this one will be B plus C cos theta. And this one will be B plus C plus D cos theta. Right, now we are taking anti-clockwise to be positive. So this one will be anti-clockwise, this one will be clockwise, this one will be clockwise. So we are going to have sum of moments about A is equal to 0. Please, this is sum of moments. Don't confuse this with the mass A that I was doing. This, I make this the mass of this A, but there is a point here labeled as A, and that's what I'm taking moment about. So taking moment about that point, I have this, the hydraulic force, which I made it Fh. So Fh multiplying B cos 60, and it is counterclockwise, but the weight you want to go down, the weight should be what? Clockwise. So minus the weight, we have 2,000, so 2,000 times 9.81 multiplying B plus C cos 60. Let me clean this part. minus 2t multiplying b plus c plus d cos 60, and then it's equal to 0. So you see, the only thing we don't know is what? H, right? FH. Okay, so a lot of small details. Yeah. It's all about concept. So if you have the concepts, you should get this. Right, so let's move on. I don't know what to actually do now, because if we have to explain every little thing, we wouldn't finish too. All right, so kindly solve for the FH for me, and let me get the answer. Or let's do it together. So b is 4. So 4 cos 60. Cos 60 is 0.5, so that would be 2. So we have FH times 2 minus 2000 times 9.81 multiplying b plus c 6, so that would be 3, and that's giving me 5891.4 minus the t we had 44240, so 2 times 44240 multiplying b, so 6 plus 6, 12, so that's a 6 here, equal to 0. So we're going to have 2 times FH is equal to, so we have minus 5891.4 minus 2 multiplying 44240 multiplying 6, so it's equal to 536,771.4. So FH will be equal to, that's divided by 2. So 536,771.4 divided by 2. So we have 268.4 kilonewton. All right. Any problem before I move on, please? Oh, Sakina, My people, why are you? Yo, I need to subscribe, guys, please. Thank you, my guy. Okay. All right. Should I leave this for you? The airplane question. I have this. This one I won't solve it. This one I won't. 14. And this guy. This guy looks some way. I'm not sure I can solve it today. But this is okay. And next. Oh, goodness. All right, sure. After this, I'll go and solve the yo-yo. Then you go and pray for the rest. All right. Should we work with this, or you guys can do that so that we can move to the next one? All right, let's do the aircrafts. Usually this question comes in exams a lot, so pay attention. No need to draw a free body diagram. You can just do your whatever on it. So we have the aircraft and are determining the acceleration. We are looking for the acceleration of the plane and the normal reaction on the nose wheel and each of the two wing wheels located at B, given these values, right? So initially at takeoff, the engines provided thrust. Okay, so we have this and this. All right. So the reaction here is 2RB. All right. Now you can make it just RB, but know that it is 2 times. So when they ask you, see they ask to find what on each of the two wings. We should solve question 10, and that's what we are doing next. So each of the two wings, if let me take it again. Right, so now this problem, we are looking for the acceleration of the airplane, and then the reactions are the nose and then the wheels and the middle side, and then over here the wing wheels and then the nose wheels, the reactions. So over here there are two wheels over there which will have the same reaction. So if I put RB, then I mean that it's a combined reaction. So you can work like this. When they ask you for each, you divide by 2 finally, or you can put 2 here, and that one when they ask you, just what you found is what you give. And I prefer that one when pair assembly. And here will be what RB. And you know, so we know sum of forces in the x direction should be equal to MAX. Sum of forces in the y direction should be equal to what? MAY. But in the vertical direction, there is no motion yet, so AY is equal to 0. So sum of forces in the y direction should be equal to 0. And for it to be in equilibrium, since we are not expecting the airplane to be rotating while it is on the ground, sum of moments about any point should be 0. Now I'm going to choose G, right? But if I don't choose G, then the inertial force, which is MA, will also come in the equation. All right, so let's deal with the X. So the forces in the x direction, we have t and 2t. So t prime plus 2t should be equal to what? max. What we are looking for is the what? Ax. Total mass is given as 2200 megagram, which is 2208. So we have 2200 times. So this is what we have for the mass. T prime is 1.5 kilonewton, T is 2 kilonewton. Please pay attention. You introduce the kilo. If not, you are wrong. So we have 2 kilonewton, which is 2000 for T. Okay, so for T prime, that is 1.5. So 1.5 times 10 power 3 plus 2 times 10 power 3. That should be equal to 2200 times 10 power 3 kilogram times, no units, times ax. So ax should be equal to 1.5 times 10 power 3 plus 4 times 10 power 3 all over 2200 times 10 power 3. And that would be equal to Mimi. So we have 1.5, so that can even cancel out. So 1.5 plus 4 all on 2200. So we have 0.0025 meter per second square. Please, is it clear at your end, please? Okay, I think it's coming. All right. All right, let's move on. If anything is not clear, hit me up on time. So we have the acceleration of the aeroplane. Now the next is to find what the reactions. So we are going to take moment about the center of what? Mass. If we don't take moment about the center of mass, then you need to multiply the mass to this acceleration, and that will be part of the forces if you're taking moment about any point apart from the center of mass. But if the center of mass are taking the moment of inertia about, since this is already at that point, that will be 0, so you don't need to do that. So I won't take moment of inertia. I won't take sum of moment about the center of what? Mass. But before you do that, we know the weight of the car is also going to act downwards, which is what? M times what? Acceleration due to gravity. Now from here we said sum of forces in the vertical direction should be equal to 0. So we have the weight, which is negative coming down, plus 2rb plus re should be equal to 0. So you can say 2rb plus re is equal to what? The weight. And so 2rb plus re is equal to, the weight is 2200 times 10 power 3 times 9.81. Okay, then you're taking moment of inertia about the center. Now pay attention. This is the part where it's very important. So there's a center, right? If you look at 2t is c, and the distance from the c to the ground, the distance from the 2t to the floor is c. and the distance from the center to the floor, to the same floor, which is F, is what? So it's okay. So the distance is F. Now look at the difference. C is, where is C? Where is C? C is 2.3 and F is 1.2, meaning the 2t is above what? The center. So if this is the center, 2t is somewhere here. So this will give us clockwise moments. And then the t prime to b. B is, where is B? However, 2.5. F is what? 1.2. So once again, you can see that t prime 2 is also what? On top. So they are all going to be what? Clockwise. And then the B is on the left. The RB is on the left. So that's also going to give us what? Clockwise moments. So it's only the, oh, why did I make this place B? So this is going to be RB, this is going to be RE. So it's only this guy that is going to give us what? Counterclockwise. And then its perpendicular distance is E. So let me bring it down. Put it here. I think here is fine. Okay. So let me clean this. So this was for the vertical. So the weight plus this is equal to 0. So 2RB plus this is equal to this. And we have this equation. Who has solved for this one? So we have 2200 times 10 power 3 multiplying 9.81. So question 1. The way you solve problems seamlessly and in differential equation approach. Goodness. All right, we'll talk about that later, right? After this session. So RB, I take a moment of inertia about the center, right? So for T prime, the distance from the center to T prime will be what? B minus F, right? So the distance from here to here is F. The distance from T prime to the floor is B, and T prime is here. So from here to here will be what? B minus F. So the moment of that one is counterclockwise. So it's clockwise. So you're going to make a negative. So negative T prime multiplying B minus F, and then 2T2 similar. So 2T, the distance is C, and then it is longer than the F, so that will give us C minus F. So minus 2T into bracket C minus F, and then the B is also clockwise. So minus 2RB multiplying D. So the force, we can see it to act in this direction. The perpendicular distance should be from here to here, which is D. Now we have what's RE. The distance is E, and it's what's counter. So we have plus RE multiplying E, and it should be equal to 0. So if we are making our substitution, T prime is 1.5. So you have minus 1.5 times 10 power 3 into bracket. B is 2.5 minus F is 1.2 minus 2. T is 2000 multiplying C 2.3 minus 1.2 minus 2 RB, then D is 3, I think. Yeah, 3. And the other guy, E. So let me bring it plus RE, and E is what? 6 is equal to 0. So you see, from here we can make some equation with RA and RB as well here. Alright, so help me with the calculation, please. Verification. 1500. So minus 1500 multiplying 2.5 minus 1.2 minus 2 times 2000 multiplying 2.3 minus 1.2. And okay, so that wouldn't be. So we have minus 6,350 minus 2RB plus RE times 6 is equal to 0. So from here we can say that 6RE minus 2RB is equal to what? 6350. This is equation 2. So this and this can help us to find our what? Unknowns, right? So we can just use calculator. At this point, don't worry yourself solving it. No need. You won't get any marks for that. Use your calculator. Where's the equations? Okay, so I'm representing X with RE and Y with what? RB. So RE, the coefficients of RE equation 1 is 1, RB is 2, and the C is 2 1 5 8 2 0 0 0. Wait, this number is too big. And then the other one we have RE is 6 and minus 2 for RB. We have 6350. Yeah. 2200. Please, who was solving with me, please? I want to verify something. Hey, none of you is here. What did you get for your reactions? I'm getting RA to be three 0 8 4 0 5 0. And RB is 9248 975. Waiting. Okay. What are the different answers? Let's discuss that before we move on. Hey, none of you is working with me. I'm already tired. Can sleep any moment from now. Where are you? Okay, so let's work with the yo-yo and maybe we'll go and sleep. Hey, killer. Okay, so the method is the same. You follow the same approach. If you get different answers, you reach out. If the same answers, that's hallelujah. Okay, so let's solve the yo-yo and then we can say good night. Why are they playing like that? Okay, so a yo-yo consists of three concentric discs A, B, and C as shown. Disc B has mass m1, so B has mass m1, but you are not holding the calculator, so how are we doing it together? So m1 is 0.24 kilogram and r1 is this A and C have the same mass. What is m2 equals 0.88 kilogram, r2 the three discs are fused together as one piece and a string is coiled around the periphery of this B to form a yo-yo. Determine the mass moment of inertia of the yo-yo about axis perpendicular to the page and passing through point 2. So over here. So I find I0 and that will be equal to I1 plus 2I2. And that will be M1 R1 squared on 2 plus 2 times M2 R2 squared on 2. So mass 1 0.24, R1 0.1 squared all on 2. Yeah, these two cancel these two, so 0.8 multiplying 0.15 squared, and that will be 0.12, 0.1 squared plus 0.88, 0.15 squared. So we have 0.021 kilogram meter squared. Okay, leave your answer in kilogram meter square. So A is done. B, use the energy method to determine how far it must descend to attain an angular velocity. This. All right, so how far it might descend to attain an angular velocity. I'll say if it's released from rest. So energy method, we have PE1 plus KE1 plus PE1 is equal to PE2 plus KE2 plus PE2 plus E loss. But obviously E loss is 0, no spring energy, so this and this goes to 0, this goes to 0. Alright, now we are looking for how far it travels, so the change in the height from here to here. Okay, so the body will be rotating while it's what? Translating. Alright, so we are considering if you are considering rotation about the center of the body, then PE over here, which is what? mgh plus kinetic energy, you have half. So you consider the translational kinetic energy, rotational kinetic energy. So half I omega naught, which is initial square, plus half mu squared should be equal to, so potential energy 2, that's where the body will stop, so that should be 0, plus kinetic energy will be half I omega final squared plus I, sorry I said I, so plus half mv squared over here. But since it was released from rest, omega naught is equal to what? U, which is 0. And also we know that v is equal to omega r. And here the radius of rotation, you know, this is where the force is applied. So radius of rotation is what? The r1. So we're going to have mgh to be equal to half I omega f squared plus half m omega r. Let me just make it omega r squared. So the total mass of the whole thing is going to be 0.24 plus 2 times 0.88. So 0.24 plus 2 times 0.88 times 9.81 times A should be equal to 1 over 2. And then I is about O. So IO is 0.021. So 0.021 multiplying, this is 60 rad per second, right? So 60 squared plus half the mass again 3.4, 0.24 plus 3 times 0.88, that is 2. So we have 2 here multiplying 60 squared multiplying, the r is r1, right? So R1, the value of R1 is given as 100, which is 0.1. Alright, so what you are looking for is H. So 2 times 9.81, you have 19.62. H is equal to 0.5 multiplying 0.021 multiplying 60 squared plus 0.5 multiplying 2 multiplying 60 squared multiplying 0.1. That is 397.8. So H will be equal to 397.8 divided by 19.62. So we have 20.275 meters over here. Okay. So we are done with how far it must descend to attain this angular velocity. And the next is to use the momentum impulse equation to determine the time it takes to attain this velocity. So with that one, all right, so no problem. Let me just bring this guy down. Okay, so the free body diagram, we are going to have T here, right? So using the momentum impulse equation, since the body is rotating and translating, we can have the translational momentum impulse equation and rotational momentum impulse equation. Now here they give us the rotation, so we can say I omega naught plus sum of moments times theta times t with sum of moments times t should be equal to I omega final. So we're going to take moments at the center, right? So at the center, this one wouldn't come in. So the center, the weight of the whole item, which is at the center of mass, wouldn't come in. So I is just IO, which we found earlier. We'll go back to that. Then the body was released from red. That is the initial preamble. So the moment at the center is just T times R1. Right, so the moment is just T times R1. But then if the T here, if you draw the free body diagram, you're going to have mg minus T should be equal to ma. So T will be equal to mg minus ma. That means the sum of moments should be equal to mg minus ma times r1. Now the ma is the mass and acceleration, which is the tangential acceleration, and tangential acceleration is equal to the angular acceleration times r. Coming, we're not giving the one that did this. Use the momentum impossible to determine the time it takes to attain angular velocity. Let's take a moment of inertia about this point. So mg times t. Okay. All right. So then is, if we use this method, we will need the angular acceleration, right? So we need the angular acceleration or the linear acceleration, which we're not given. So you will, let's finish the expression and see what we don't have, and then we'll see that which method we should use again. So mg minus mt times r r1 multiplying t should be equal to I naught omega f. So here we know the mass, gravity, we know. We don't know this guy here. We know use the equation of motion to determine the linear and angular acceleration. So we don't know the acceleration yet. R1 we know t. Okay, we don't know t. All right, so the other method is to find the moment of inertia at this tip here. All right, and then when we want to find the moment at this tip here, then we're going to have the I to be equal to I naught plus m I naught plus m omega md square, right? And then this time our d is what? The r1. So so we're gonna have I omega naught plus the sum of moments about, let's label this place b, about b times t should be equal to I omega f. So this time this will be 0 plus the moment will just be the weight, which is mg times r1. So we have mg times r1 times t to be equal to I as the b omega f. So the total mass, that will be 2 times r1 to 0.1 times t should be equal to I naught plus md squared. So I naught we had where is I naught? I naught we had 0.021. All right, so we're going to have 0.021 plus 2 multiplying r1 to 0.1 squared multiplying 60 rad per second. So you can easily get the moment of inertia. See the difference between this and the other one is that here we had to find the angular acceleration or linear acceleration before we can have this expression. And since we don't have that, that will be a problem. So now we can find out t, and t will be equal to 0.0 0.021 plus 2 times 0.1 squared multiplying 60 divided by, okay, so 0.021, okay, times 60, that'll be 2.46. So 2.46 divided by 0.2. So we have 12.3 seconds. So we have the time, and use the equation of motion. Use the equation of motion to determine the linear and angular acceleration of the disk, and determine how far the area must descend to attain angular velocities. Okay. The equation of motions. When the book talks about equation of motions, there are two: either the force equation or the V equals whatever it is. So let's use, because they're asking you to find the equation of motion to find the linear and angular acceleration, and then from the above determine how far the area will descend to obtain this, and compare to this. From the above determine the time it takes to obtain this compared to this. Okay. So right, so the equation of motion, we have the sum of forces is equal to mass times acceleration, and we have sum of moments is equal to I alpha. Right? So sum of forces, I think I did it earlier over here. So the free body diagram, we have upward, you have the tension, and you have the width, and then you can take moment at any point, right? So you can take moment at this point or at the center here. So if you're taking moment at this point, then we will have the moment to be the mg times r, which is what we used here over here, mg times r1. So mg times r1 is the moment about the point here. You can find it at the center, but if you find out the center, then we need to substitute for tension, which is we have to come and employ this equation, which is over here, right? So it's either you find the moment of inertia about the center. So for that one, you will have the tension times R1. Now you come and make this substitution, you should get the same thing. Okay, so here we have mg r1. Mg r1 should be equal to I, let me label, we said that point is B, so IB alpha. Right, let me show why they are the same. So this is it, and then if I want to find, okay, well, IB, the I at the point B, which is the point where the tension is attached, right? This point. So we are taking the moment at this point. The tension wouldn't come in because it's passing through that point. So IB is just I at the center plus mr squared, which is I not, in fact, calculated for that already. And this is the total mass, and then this is the R1. This is R1 squared, which I think I did here. This one, right? So over here, if we take the moment of inertia about the center, then it's going to be TR equals I naught alpha, right? And then the T was this, right? So we can see mg minus MER is equal to I naught alpha, and this R is R1, don't forget that. So you're going to get mgr1 minus mer1 is equal to what? I naught alpha. So you get mgr1 because I naught alpha plus m alpha r1 squared. You see mgr1 equals what? IB alpha. You see, if you can factorize alpha out, and you factor alpha out, you have I naught plus mr1 squared, which is the same as this. So using this method or this method is the same. So having understood that we are looking for alpha, right? So here the IB we calculated for, and then where is it? We had, oh, I didn't simplify. So 0.021 plus 2 times 0.1 all squared. So that will be 0.021 plus 2 times 0.1 all squared. So IB becomes 0.021 plus 2 times 0.1 all squared. So we have 0.041. So the total mass is 2. We have 9.81. R1 is 0.1. And that is equal to 0.041 times what? Alpha, right? So here alpha would be equal to 2 times 9.81 multiplying 0.1 all on 0.041. So we have 47.853 rad per second square. So A is equal to alpha R. So you can say A is equal to 47.853 times 0.1, which is equal to 4.78 or 4.79 meter per second squared. So this is the angular acceleration and this is the linear acceleration. Okay, so now this is done, this is done, this is done. So we want to find the moment, the distance it traveled to attain this one, how far it traveled, and then we want to find the time it takes to, well, so we can use the linear velocity. So the linear velocity is equal to omega r, right? So final velocity will be equal to 60 times 0.1, which is what, 6 meter per second, right? So using v squared equals u squared plus 2as to attain 6 meter per second from 0 to times 4.79 times s. So we have 36 divided by 2 times 4.479. 2 into bracket 4.79. So we have 36 over 9.58 plus s, and s will be equal to 36 over 9.58. Yeah, 0.76 meters. They said use that to compare your answer in I above. That is huge difference. You have 20 point something here. Okay, then the last one, I have to go through this. I don't know if I've made a mistake somewhere, but the distance, the displacement using this equation is too much from the energy method, which shouldn't be so. All right, so let's do the last one. I'll go through it in the morning and see. So determine the time it takes to attain angular velocity. This, so omega final should be equal to omega initial plus 2 minus alpha t. All right, and then we have omega final to be 60 to be equal to 0 plus, and alpha was 47.853. So t will be equal to 60.853 divided by 47.853. So t will be equal to 60.853 divided by 47.853. So I have 1.271 here seconds. With this one is 12.31. All right, so yeah, this is what I have, and this way we are ending. I would have to go through this question again. If they're the same, fine. If there is mistakes too, yeah, I will rectify that in the morning and then we can get a solution. Okay, so we end here. God willing, tomorrow I'll go through the rest and send the solution to your course rep to send them to you. So